UIST, take 2.
Hi, my name is Pedro Lopes and I run the Human Computer Integration Lab here at the University of Chicago. Today, I have the pleasure of presenting our 3 new UIST 2025 papers from our lab to you. The first is primed action. Yudai Tanaka is here to show us. Come on, Yudai.
Hey, I'm Yudai Tanaka, and I led this primed action project.
So, primed action follows kind of a long tradition of work in our lab about reaction time. How can we speed human movements? We've tried a number of different things, but I first want to show you what reaction time studies look like usually. Here's a prompt, and I'm going to react as fast as I can to it. That's a typical reaction time test. We've tried things like muscle stimulation, like stimulating my muscles to cause an involuntary movement. It's really fast and speeds my reaction time, but it doesn't feel like I'm the one doing it. And we've also tried brain stimulation, which is what Yudai is going to try here on my brain. So I'm just going to align my motor cortex with this electromagnetic coil. And then we're going to try a reaction time test where Yudai is going to stimulate my brain to be faster than normal. So we're going to start the test. Whoa, that was super fast. It was very fast, but the problem is I was forced to move. Yudai is actually going to show you again that this is an involuntary movement.
Yeah, so what happened here was, like, as you can see, Pedro's body is moved by this brain stimulator device, not by himself. That's why he didn't feel he did the button press, or he did move his body. So as you can see here, this intensity, the brain stimulation, involuntarily takes control of his body movement. So we are not interested in this intensity exactly, so we keep lowering this brain stimulation intensity. So let's see, at this intensity, it barely moves Pedro's body. Let's call this the threshold of involuntary movement. But we are not even interested in that. What we are interested in is further lower, where this point, this brain stimulation doesn't even create any movement, or Pedro doesn't even feel any sensation in his hand that is externally coming from the stimulation. But what's cool about this low-level brain stimulation is that it can still slightly charge up the neurons in the Pedro's brain's motor cortex. What that means is that by that way, Pedro's brain can be more quickly generate the command to drive the muscle and move the body. That's how we believe and how we validated that how this primed action technique can speed up Pedro's reaction time. So let's see how it works.
Okay, we're going to start another trial of this reaction time. So this time I was slightly faster, rewind the video, watch it in slow-mo,
Yeah.
Slightly faster, but it was my command. As Yudai shown you, this coil, you can take it away, produces no visible twitches. It just charges me up to be slightly faster. Now we're going to change gears, and we're going to go into the world of virtual reality. So I'm going to switch computers as well so you can see what I will see in virtual reality. So I can show you our second paper. This was led by Kensuke Katori when he was an intern in our lab. All right. What you're seeing in this virtual world is a very popular illusion in virtual reality called hand retargeting. So in the hand retargeting illusion, I am moving my hand into this cube here, and I place a physical prop, a real cube, under my hand. This makes VR sound real nice and really immersive. However, I would require as many props as virtual cubes. You see the pink cube over there? There's no prop under the pink cube. With a technique called hand retargeting, which we didn't invent, it's really, really popular, you can move the visual avatar of my hand, just visually, in a way that my body will compensate for it, and we will land on that pink cube at the same location of the physical prop. Yudai, are you ready?
Yeah.
Okay. So this is still unretargeted. Maybe you can turn it on. There we go. I think now we're being retargeted. Now we're being retargeted. You see, I'm at the location of the pink cube. I'm under the prop. That's the traditional retargeting illusion. However, I can tell you that felt artificial. I even kind of stopped halfway through it and I was questioning if this was part of my body. It's just too much movement, too many sensory conflicts that I did not expect to truly believe this new movement was my hand. This is where we entered with a new technique. Behind my ear is an electrode, very close to my vestibular organ, my sense of balance. What we can do is with this electrical stimulator right here, perturb, stimulate my sense of balance. You guys are going to do that. Okay. I swayed that way. And now I swayed that way. This is electrically induced balance disturbance. This is really, really cool technique. Now, we're going to use this to make what you just saw feel coherent. Because as I'm approaching the pink cube, my virtual hand goes way off to that side. And we're going to perturb my sense of balance a little bit so the experience feels coherent. I expect that if my hand is like that, my balance shifts by a little bit. We're going to now fine-tune that shifting by just a little bit to feel more coherence. And that way, I won't be bothered by the illusion so much. I will actually believe in the illusion. That's what we found in our study. So Yudai, can I try it?
Yeah.
Okay. So there we go. I felt a little sway because I was paying attention and Yudai is doing it over the threshold. But in our study, we do it so subtly that users do not feel this disturbance here, and yet they believe more in this illusion. In fact, we can widen how much we can retarget your hands before you notice. That's what galvanic vestibular stimulation can do for the idea of hand retargeting. Now for our third and final paper at UIST 2025, which was led by Antonin Cheymol when he was an intern here with us, I'm going to go back to this experience, to the hand retargeting. Imagine, I'm still retargeted, right?
Yep.
I believe these things so much that I sometimes don't know. I'm still in this world of hand retargeting. You would expect that normally when I lift the VR headset off and come back to reality, all my senses automatically reset back to reality. That is not what we found in this paper. Here's what we found. That after experiencing hand retargeting, if something rapidly prompts my attention in the real world, like this alarm, my feeling of hand position is still affected by the hand retargeting. I was actually thinking that my hand was here, and that's why I missed pressing, this prop of an emergency button. We found that these virtual reality side effects not only exist when you're in the experience, but even when you remove the device, they linger as side effects into the world. In fact, not only hand retargeting can linger, we also found that if you had a replica of this button placed in the virtual environment in a different location, I would start to confuse the memories of the virtual button and the real button. And in our study, people got out of the virtual experience trying to reach for the real emergency button, and they went for the virtual one. They started conflating those two illusions. That's our third paper. It's called VR Side Effects, and that concludes the 3 new papers that we have from UIST 2025 to present to you.